Hello, in this mini lecture I will introduce canonical forms of Boolean functions. There are two. First is a canonical sum of products, and the second is canonical product of sums. Okay, an example is a function which detects the visibility of by 2 and 3. Yeah, you know this function. It is AF if you've got a truth table. As you remember, there are 8 rows in this table, and please, apart from the sequences which are binary sequences, put the decimal counterpart of each of the sequence. So 0, 0, 0 means 0. This is 1, 2. That's a consecutive numbers in decimal. Okay, so you simply number the rows in the truth table starting from 0 and finishing to 7 in this case. And as you remember that the divisibility 0 is divisible by 2 and this is not, by 1, by 2, by 3, by 2, not, by 2 and 3, and not. Okay, and instead of this, to define this function AF, you can simply look at on the rows where the function is 0, only 3 rows, function 0, and you express it as a product of sums. This is suitable for zeros. A, B, C. What is this? It is the product. It's a pi. It's a pi. In mathematics, it is a arithmetic multiplication. In this case, it is a logic one. Okay, it is logic multiplication. It is a product, a logic product, conjunction of. And you put in parentheses the numbers of rows where the function is equal to 0. Where the function is equal to 0. These are 1, 5, and 7. It is the canonical product of sums. You can also define this function using canonical sum of products. And the sum symbol is the sigma symbol. And then there are the numbers or the rows in decimal where the function is equal to 1. There are 5 of them. So the first is 0, then 2, 3, simply the ones which are not present here, okay? But not over 7. 7 is the maximum, okay? Because the last row is a 7. For 3 variables, you don't have more than 7 rows starting from 0. So these are two canonical forms. This is a product of sums, and this one is sum of products. Okay, for each function, for each logic function, you can express it in the two forms. Let's consider the function which is simply A XOR B. Do you remember when this function is equal to 1? It is a sigma. Sigma is a sum of products. So you must look at ones in the truth table. In the truth tables, there are 2 ones in the second and third rows. But the second row is numbered 1 and the third is numbered 2 because we start with 0. So 1 and 2 is the solution. Yes, it is the sum of products canonical, and pi, of course, the ones which are not present. In the previous one, it is a product of sum and sum of products, canonical forms for XOR. Let's consider AND, A times B, which is AND, which is a sigma AND. What inside? How many ones there are there in the truth tables of AND? only 1 when a and b are 1. So it is the last row. The last row for two variables is numbered 3. And pi gives you zeros, and zeros are in the rows 0, 1, 2. And so on, and so on. And let's consider, I hope you remember, cout of full adder, ABC, is equal to, and S, that is the sum of full adder of ABC, is equal to. Do you remember? You remember, I hope, the cout is AB plus BC plus AC, and carry out occurs when you've got 2 or more ones in the input sequence. So 0, 1, 1 gives you 3, 1, 0, 1 gives you 5, 1, 1, 0 gives you 6, and 1, 1, 1 gives you 7. So this is the canonical form. And pi, of course, which ones are not present here, 0, 1, 2, and 4. And similarly, sum. As you remember, sum is XOR of A, B, and C. A XOR B XOR C. That's the shortest equation, Boolean equation. And I hope you remember from the face-to-face lecture that the definition of XOR of any number of variables is that it is equal to 1. I am interested in ones in truth table. Is equal to 1 when the number of ones in the input sequence is even or odd? Is odd. So a single one, 0, 0, 1, 0, 1, 0, and 1, 0, 0 gives you 1. So it is 1, 2, and 4. And the last sequence, which gives you XOR equal to 1, is the odd number of ones, which is 3 ones, 1, 1, 1, which is 7. Okay? So for these sequences, XOR of A, B, C is equal to 1. For the remaining ones, so 0, 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 1, and 1, 1, 0, the result is 0. So it is a pi, yes, for 0, 3, 5, and 6. 0, 3, 5, and 6. So we can express XOR in this way, and cout in this way, and the function can be expressed very easily and in a compact form using canonical form, sum of products using sigma symbol, or product of sums using a pi symbol. Thank you.